Okay, let's go ahead and identify these cations and anions and names. So, what's the oxidation number for the cation in this first one? Why does hydrogen have a +1 charge? Because it's paired with a non-metal. Yep. And the fluoride is a -1 because in a compound fluorine is always -1. And the name of this?
Hydrofluoric acid.
And it starts with an H, so it's an acid, and there's no oxygen there. So we start with hydrofluoric acid. Okay. Next one, cation.
Calcium.
Why is it +2? Because it's a column 2 metal. Okay. And then oxygen's got a -2 charge because it has to be. And then the name of this?
Calcium oxide.
Why don't I need to say calcium 2 oxide?
Because it's always 2.
Because it's always 2, so you don't say it. Okay. Next one, the cation. Okay. Cadmium's +2. And then the bromine? -1. And then the name of this? Why is it not cadmium 2?
It's a group 2.
It's not. It's not a group 2. But it is always +2. It is a transition metal, but it's one of the 3 transition metals we talked about that have a fixed oxidation state, so you don't call it 2. Okay. How about the cations in number 4? Okay, so I got a hydrogen and its charges
Or +1.
+1 because it's with nonmetals. Anything else? The phosphorus. The oxygen's got a -2. So there's 8 negatives, and then there's 3 positives with the H's, so that makes the phosphorus a +5. Are we okay with me assigning a +5 to phosphorus? In the name? Why is it phosphoric acid?
Because it's phosphate.
Because it's phosphate, because it's PO4. And how come it's not hydrophosphoric acid? Because there's oxygen there. Okay. Next one. Which one of these two things is going to be the anion? The oxygen, because it's got a higher electronegativity. Okay, and its charge is going to be -2, and then that means that my bromine is the positive one, and so the only way this works is if the bromine has a +3 charge. So if it's a +3 and I've got 2 -2s, then that leaves me with a -1, and then I've got the polyatomic ion, what? Bromite. Okay. And the next one?
I have a question.
Sure.
I've heard it called bromide one time. So I heard it called bromide.
2 up is bromide. What is bromide? 2 up.
Oh, that's it's a anion.
Say again?
It's an anion.
They're both anions.
Oh, okay. Is it?
The bromine by itself.
Oh,
When the element is by itself, we'll call it ide. We'll throw the ide onto it.
Can we go on that one again?
Sure.
Can you, I'm sorry, explain why it's +3 for the bromine?
Sure. So this is a polyatomic ion that has an overall charge of -1. So we're not going to cancel out the charges.
Oh,
We're only going to cancel them out to give a leftover -1.
Okay.
So I've got 2 oxygens, and both of them are -2. So my total negativeness is 4. And I need to cancel out 3 of that 4. And so to do that, then I make my bromine +3.
Okay.
Are you okay with that?
Yeah.
All right. And my next one? Who's my cation?
Copper.
And the copper's charge?
+2.
And then the chlorine?
-1.
And then the name of this?
Copper 2 chloride.
Why copper 2 chloride, not just copper chloride?
Because there's a transition.
Because it has a variable oxidation state. Okay, next one here. Cations?
Sodium.
Na with a plus, H with a plus, C with a +4, and then oxygens with a -2. And what is this?
The hydrogen carbonate.
What's the common name for that?
Sodium bicarbonate.
What's a more common name for it? Baking soda. Yeah. Okay, we've got silicon dioxide. So what's the formula for silicon dioxide? Already? And then the oxygens are a -2, and then that makes the silicon a +4. What's the common name for that?
Sand.
Or,
Glass.
yep. All right, so we've got dinitrogen pentasulfide. So what's the formula?
N2S5.
N2S5. S -2. N +5. We good with that? Ammonium dichromate. Formula for that?
NH+4 parentheses.
What's next to the parentheses? 2. Okay. And then CR
CR2.
207. Okay. So lots of stuff going on here. We'll take care of a couple things. We'll put oxygen as a -2, and we'll put hydrogen as a +1. How are we going to figure out what the nitrogen's charge is?
Ammonium is the overall charge of +1, right?
Yeah, so that's exactly how you should do this. When you get a double polyatomic ion, you should take the substance and split it in half and figure out what the charge of the substances are inside of the polyatomic ion, regardless of what it's combined with. Because ammonium's charge is +1, and it doesn't matter what it's paired with, its charge is +1, which means the oxidation states of the atoms in the polyatomic ion are set. So when you get a double polyatomic ion thing, just separate the 2 polyatomic ions and figure out what their charges are together. So the ammonium is a +1 charge. There's +4 from the hydrogens. So what's the nitrogen's charge got to be?
-3.
-3. That way it cancels out 3 of the 4. So then it's N with a -3. Okay, so if I've got -2 for the oxygens, and the dichromate's overall charge is a minus what? 2. Okay, and so I've got 14, and 2 have to be left over because it's a polyatomic ion with a -2 charge, and I've got 2 chromiums. So the chromium's charges are what?
6.
6 each. That's about as hard as it gets. Hydroxide, what's the hydroxide's formula?
OH.
A little more?
OH negative.
Okay. OH with a negative charge. The hydrogen is with a non-metal, so it's +1, and then the oxygen's got a -2 charge, and that's it. Mercury 2 iodide, well, that one's pretty easy. So I've got an Hg and then an I2, and the charge on the mercury is 2 because it told us it was, and then the iodine's charge is a -. And how about the zinc fluoride? The zinc's always a +2, so then I need 2 fluorines to go with that, and so since the zinc's always a +2, I can just write that, and fluorine's always a -1. This acid's name? And the formula for the next one? Okay. And then the name for the C2H03 or CO3? And then the phosphoric acid? And then how about this one? What's this guy's name? Chromic acid. Okay. And then acetic acid. Yeah. And then
or C2H3O2H.
yeah, sure. And then the HBrO3. Which definitely differs from this one up top, right? Bromic and hydrobromic. And then the last one, perchloric.
HCl4.
Okay, that's good. So what's the first thing you're supposed to look at when you're naming a chemical formula?
What kind of compound it is?
Yeah. So we're looking for ionic, covalent, or acid. I need to know which one I'm looking at so I can name that. How do you know if a compound is ionic or covalent? Are there any exceptions?
That's non-metal or metal.
Okay, so if I've got a metal and a non-metal, that's going to be ionic. And if I've got a non-metal, then that's going to be covalent. And the exception is this could be NH4 plus. Then I have all non-metals. So NaCl is a covalent. NaCl is an ionic. CO2 is a covalent, and NH4Br is also an ionic because of what reason? There's an ion there. The ammonium ion is there. Even though there are no metals there, this is an ionic compound because there's the polyatomic ion ammonium. Questions? What? So you can know almost every single ionic compound has a metal in it. If there's a metal in it, what kind of compound am I looking at? Ionic, period. Nothing else to say. It's an ionic compound. It's got a metal in it. Okay, great. Well, is there an exception to that rule? If you use ammonium ion, then it's NH4 something, and there's no metal there. But why is it still an ionic compound? What is this thing? It's an ion, so it's an ionic compound.
Is it because the H falls in that?
No, it's because it's a charge. There isn't any, it's not because it's in column 1 or any, it's because ammonium is a charged particle, so it's an ionic compound.
Am I right with the acids, like go
one